Hello everyone, we will discuss on how to solve LP problem by using Big M method. Now, this is our LP problem. The first step is to convert to Tableau form. So, we got the Tableau form like this. Basic variable and non-basic variable will be like this. We need to write the initial Tableau based on the Tableau form. So, the initial Tableau will be like this. Remember that all basic variable must have 0 coefficient in row 0. To eliminate A2 from row 0, simply replace row 0 by new row 0. Then, the new row 0 is row 0 minus row 2. We write it into the updated initial Tableau. Row 1 and 2 remain the same as before. As for maximum problem, all coefficient in row 0 must be non-negative, thus the LP problem will be in optimal condition. Hence it means that this LP problem is not in optimal condition. So, we need to choose the most negative coefficient in row 0. x1 will be the entering variable. Then, we need to select the leaving variable by using a ratio test. A2 will be the leaving variable, as it has the smallest non-negative ratio. Now, we need find the arrow on how to make number 6 in row A2 column x1 equal to 1, number 36 6m in row Z column x1 equal to 0 and number 1 in row S1 column x1 equal to 0. So, we will get the arrow and Tableau 1 like this. For Tableau 1, x4 will be the entering variable as it is the most negative coefficient in row 0. S1 will be the leaving variable, as it has the smallest non-negative ratio. There is an BV with non-positive coefficient in row 0. There is an BV with a negative coefficient in row 0 has a non-positive coefficient in each constraint. Thus, this LP is unbounded feasible region. As x1, x3, x4 are increased, Z will increase. In summary, the unbounded LP occurs when one wants to enter the basis, but the ratio test will fail.
We find the dual LP for this problem.
So, this is our original problem or known as primal problem. Before we construct the dual LP, we need to know a few rules, which is shown in the table. The first step we must do is to identify what is the problem for dual. Is it maximum or minimum, how much variable that will have and how much constraints that will have. We get all of the information based on the primal problem as dual is like a twin for primal. For the primal, the problem is maximum, the variables is 4, the constraints is 2. For the dual, the problem is minimum. As we know, the number of variables in the dual problem is equal to the number of constraints in the original, primal, problem, thus the variables for the dual is 2. Next, the number of constraints in the dual problem is equal to the number of variables in the original problem, thus the constraints for the dual is 4. Now, we can construct our dual LP problem. So, this is our dual LP problem. We find the dual solution for each of the LP based on their optimal Tableau. As we can see the table below, is the optimal Tableau. Now, we need to find the value of W, Y1, Y2. To find the value of Y1 and Y2, we need to refer to this table. This is the maximum problem. So, for the first constraints, the sign is less than or equal to, so y_1 is equal to value of s_1 in optimal row 0 of the primal LP, which is 12. For the second constraints, the sign is equals, so y_2 is equal to value of a_2 in optimal row 0 of the primal LP, which is m plus 4m, so the answer is 4. Lastly, W is equal to optimal Z, which is 100.
This video, I want to show how to solve linear programming problem. Use the Microsoft Excel. First step, set the setting add solver function to Microsoft Excel. Type variables. Then highlight here. And now, in this question we have 4 variables. x1, x2, x3, and x4. Make them all 0. Next, insert objective. So, the objective in this question is want to maximize z equal to 36 times x1 plus 30 times x2 minus 3 times x3 and minus 4 times x4. After that, add the constraint. Type the number of constraints. Type inequality at here. And RHS for right hand side at here. And fill the constraint as I did. After finish, click Data and click Solver to solve the problem. Then, to set the objective, click at here Set Objective and click here on the box you have filled objective. Then set to maximize. Then in this box set a variable like this. And the last one add the constraint as I did. Then choose Simplex LP. Click Solve. So, max value for z is z equal to 100 with x1 equals 5, x2 equals 0, x3 equals 0 and x4 equals 20.